Hello everyone and welcome back. So I'm Gaurav Chopra, live from ICAI, and in today's session we are going to start our next chapter, which is theoretical probability distribution. Yes guys, this chapter is the most important chapter of statistics, and the chapter is theoretical distribution, also known as probability distribution. This chapter is also known as probability distribution. So this chapter is basically a continuation of the chapter probability. All right. So let's see who all are live with us. Patel, Mukesh Bhai is there. Pushpa Kumari, Dinesh Engel, Ajit Bha Ghosh, Betalwa, Manisha, Ayushi, Vidhi. Welcome everyone and very good afternoon. So good to see you once again, everyone. So in today's session, we are going to discuss about the probability distribution and its first portion. So this chapter is basically divided into three different parts. So we will complete this chapter in three sessions. All right. We will be completing this chapter in three different sessions. So let us understand some of the basics of this chapter. What this theoretical distribution means. Let us take one simple example. Let's say if we are talking about a coin. If we toss the coin, then what is the probability of getting heads? What is the probability of getting heads? The answer is very simple, that probability of getting heads is 1 by 2. It's simple. And what is the probability of getting tails? It is 1 by 2. This we have done in the previous chapter, that is probability. But now if somebody says, if we are tossing 100 coins, if we are tossing 100 coins, then on how many coins we will get heads? On how many coin we will see head? Now this you have to answer. Come on everyone. Yes, some more people are live now. Bhumika, Ankit, Mayur, Jyoti, Prema, Mansi. So we are tossing 100 coins. Now from these 100 coins, you have to answer how many will show head and how many will show tails. So if we check, or let's say if we try 100 times, then what we will see, every time we will get different result. If Mr. A throws 100 coins, he will get, let's say, 40 heads and 60 tails. Mr. B is doing the same, he is getting 70 heads and 30 tails. Everybody is getting the different answer, but here we have to answer theoretically, like on an average basis. On an average, what will happen? That means we have to find out the frequency theoretically. So what we are trying to do here, we are trying to find out theoretical frequency. TF means theoretical frequency. Now how to calculate this frequency? Now to calculate this frequency, we have to multiply two things. We have to multiply two things. One is like the n, which is the number of coins in this case, with probability. N multiplied by the probability. So if we are talking about heads, then how many coins we are tossing? We are tossing 100 coins. And what is the probability of getting heads? It is 1 by 2. So 100 multiplied by half. We are getting 50. We are getting 50. Similarly, if we are talking about tails, on how many coins we will see tails? So 100 multiplied by half, again, it is 50. It is 50. So on 50 coins, we are getting heads, and 50 we are getting tails. Now, is this the exact number what we are getting? Actually, no. This is the theoretical frequency. That means we are calculating with our formula. All right. So on 50 coins, we will get heads, and on 50, we will get tails. Yes. So most of you have given the answer. That's correct. Now, similarly, let us take one more example. If we are throwing, let's say 30 dice, we are throwing this time 30 dice. Now 30 dice means what? Now on how many dice we will get number 1? On how many dice we will get number 1? So for getting the number 1, we have to multiply the two things. One is n and second one is probability. So what is the value of n? It is 30. And what is the probability of getting number 1 on the dice? It is 1 by 6. So let's multiply 30 into 1 by 6. We are getting 5. So on 5 dice, or we can say 5 times, we will get number 1 on the dice. 5 times, we will get number 1 on the dice. Similarly, what we can do, we can find out the number 2. Now, number 2, it is the same thing, 30 multiplied by probability of getting number 2 on the dice is again 1 by 6. We will get the same result, that is 5. So this is all about the theoretical frequency. All right. This is all about the theoretical frequency. Now, if we talk about this chapter is divided into two types of distribution. One is the discrete probability distribution, and second one is continuous probability distribution. One is discrete and second one is continuous. Now, in the discrete type of distribution, we will be studying binomial and Poisson. We will study binomial as well as Poisson. And in continuous distribution, we will be studying the normal distribution. All right, we will be studying normal distribution. Now, besides these kind of distribution, there are some other distribution as well, but they are not in our syllabus. Like, let's say in continuous distribution, there are some more like T distribution. There is one F distribution. There is one chi-square distribution. So there are variety of distribution, but all these are not in detail. All these are not in our syllabus. All right. So what we have to study, binomial distribution, Poisson distribution, and then the normal distribution. All right. So now, what is the first theoretical question which we have to remember? That is the binomial and Poisson. These two are the parts of discrete probability distribution. These two are the parts of discrete probability distribution and continuous. So in continuous distribution, we are getting the normal distribution. All right. Now, we have discussed the basic. Now we are moving towards the first distribution, which is known as the binomial distribution. Okay, the binomial distribution. Yes, welcome back everyone. So many of you are saying welcome back. That's great. And many of you have also given the answers. Good going. Okay, so now we are talking about the binomial distribution. Now there are some conditions when we can apply this binomial distribution. So let us understand this first. One of the most important and frequently used discrete probability distribution is the binomial distribution. That means binomial is one of the best distribution if we are talking about discrete probability distribution. And it is derived from a particular type of random experiment which was given by Bernoulli. So it is also known as Bernoulli's process. It is also known as Bernoulli's process. All right. Now, there are certain conditions here. So let us understand some conditions. So you can write it down. Conditions for binomial distribution. Conditions for binomial distribution. Now, the first condition says we are performing some trials. What we are doing? We are performing some trials, or we can say experiment. We are doing some experiment. How many times? N number of times. We are repeating the experiment n number of times. Now, what will be the value of n? This n is always a finite number. This n should always be a finite number. Like, let's say if we are talking about tossing a coin, then coin can be tossed 5 times, 10 times, 20 times. That means it is a finite number. n is a finite number. Then second, it should be a whole number. N should be a whole number. Whole number means what? It is 1 time, 2 time, or 3 time. We cannot say that we are tossing coin 2.5 times, 3.25 times. No, that is not possible. We can toss the coin 1, 2, 3, 4, and so on in whole number, but not in case of decimals. And also, n should be a positive value. N is a positive value. We cannot toss the coin -2 times or -5 times. All right. So what are the features for number of trials? First one, it should be finite number. Second, it should be a whole number. And third one, it should be a positive number. All right. Then second one. Now, what we say about the events. Here the events are independent. When events are independent, then we have to use binomial distribution. Now, what do we mean by independent events? You must have discussed this point in the previous chapter, that is probability. Now, those events which does not affect other event are independent events. Like again, if we are talking about coin, like we are tossing coin for the first time. Now what we will get? We will get either head or tail. Let's say we got head. Now again we are tossing for the second time, and now this second time what we will get? Now second time also we can get either head or tail, so it will not be affected by the earlier event. So earlier event will not affect this. So again we can get head or tail, we can get anything. So whenever the previous outcomes are not affecting the present outcome, then the event is independent. So here the event should be independent. And next, the third condition. Now what about the third condition? The third condition is there are mainly two outcomes. One is success and other one is failure. There are two outcomes. One is success and other is failure. Now for the success, we can denote it with small p. Success is denoted by small p and failure is denoted by small q. So there are only two outcomes. One is p and second one is q. All right. Now, since there are two outcomes and these two outcomes are mutually exclusive, these two outcomes are mutually exclusive. That means we can say that also they are exhaustive. Now, mutually exclusive means one at a time. Either the person will pass or the person will fail. Both cannot occur together. Like we cannot say a person is getting pass in CA foundation as well as is getting failed in CA foundation. No, there will only be one result, either pass or fail. All right. So there will be success or there will be failure. Both cannot occur together. And second thing is they are exhaustive. Exhaustive means the total of these two will be 1. The total of P and Q will be 1. So we can write that P plus Q is equal to 1. This implies P will be 1 minus Q, or Q can be written as 1 minus P. Q can be written as 1 minus P. All right. So these are the 4 basic conditions to apply the binomial distribution. So you have to write all these conditions in your notebook so that you can revise easily. You will get recall each and everything. So what about the first condition? That is the number of trials. Number of trials should be finite, a whole number, and a positive number. Second is events must be independent. Independent means one will not affect the other. Third one, outcome. There are only two outcomes, success and failure. These two outcomes are mutually exclusive as well as exhaustive. So their total is equal to 1. So P plus Q is equal to 1. So all these are the conditions for binomial distributions. All right. Now we have to learn some of the formulas, like how we will solve the questions based on binomial distribution. So let us write some of the formulas. So formulas for binomial distribution. Now, in this chapter, the main thing is basics. If we are strong in basics, then of course we will solve each and every question easily. You will be able to solve each and every question very easily. So it is important to strong the basics first. All right. So let us write the first formula. The first formula for binomial distribution is to calculate mean. Now, mean can be written as mu. Mean can be written as mu. Now, what is the formula for mean? It is simply n multiplied by p. N multiplied by p. Second formula is variance. Second formula is variance. And the formula is NPQ. NPQ. The third formula says standard distribution, and the formula is root of NPQ. Root of NPQ. And now there is a fourth formula for probability, which we say NCX is equal to, or we can say formula for probability is NCX equal to, NCX multiplied by P to the power of X and Q to the power of N minus X. NCX, P to the power of X and Q to the power of N minus X. So these are the four main formulas for binomial distribution. First one is mean, N into P. Variance, NPQ. For standard deviation, it is root of NPQ. And the last one, that is probability, is NCX, P to the power of X and Q to the power of N minus X. All right. So everyone has got till here. Anyone is having doubts? Everyone can comment here. And if there is doubt till now, you can ask, or you can write crystal clear if it is all clear. So these are the four formulas. Come on, guys. You can comment down and let me know your status. All clear, or is there any kind of doubt? Yes, sir. Got it. Got it. Clear. No doubt. Yes. Perfect. Now, what is the meaning of these terms? See, we have written N here. N means what? Number of trials. All right. Then P. P means probability of success. Then we have written Q. Q means probability of failure. And then we have written X. X means what? X means the required number. Whatever we have to find out, we have to calculate. That is X, the required number. Okay, so these are the four things: N, P, Q, and then X. Now let us understand some of the questions. Okay. So now let's do some basic questions. Let's say if we are talking about a dice, we are throwing a dice 12 times. We are throwing a dice 12 times. So let us write tossing a dice for 12 times. So now what will happen? If we are asked about find the mean for number of sixes on the dice. Now the question is saying find mean for getting number 6 on the dice. Now what are the given values in this question? So there is n because we have tossed the dice for 12 times, and also we are given number 6 on the dice. So what is the probability of getting number 6 on the dice? The probability is simply 1 upon 6. Now what we have to calculate? We have to calculate mean. So mean is denoted by mu, and the formula is n multiplied by p. So 12 multiplied by 1 by 6. How much we are getting? We are getting 2. So this 2 is nothing but the mean. This 2 is mean. And if in the same question, if we are asked to calculate the variance also, if we are asked to calculate variance, then what we have to do? N, P, Q. Now what is N? 12. P is 1 by 6. And what is Q? So we have written that Q means 1 minus P. Q is equal to 1 minus P. So 1 minus 1 by 6. How much we are getting? 5 by 6. So P is 5 by 6. Now we can solve this and get the result. So what is the final result? 5 by 3. This is variance. 5 by 3 is the variance. All right. Yes. Petildwala has given the answer. Manish has given, Bhumika and Dinesh Ingle. Everyone is correct. So this one was the basic question. Now, let us understand some more things. Now we are talking about example number 1. A coin is tossed 10 times. We are tossing the coin for 10 times and assuming the coin to be unbiased. Unbiased means what? The coin is perfect. That means there are equal chances of getting heads and tail. That is unbiased coin. Now, what is the probability of getting 4 heads? We have to find out the probability of getting 4 heads. Okay. So let us solve this question. So example number 1, we are talking about probability of getting 4 heads. Now, whenever we are calculating the probability in binomial distribution, we are having the formula NCX, P to the power of X and Q to the power of N minus X. And in order to apply this formula, we have to find out 4 values. What we have to find out? 4 values. One is N, then P, Q, and X. All these 4 values we have to find out. Now, first is N, that is number of trials. So, how many trials are there? So, we can say that there are 10 trials because the coin is tossed 10 times. Okay. Then, how many heads are required? The required number, X is the required number. So, X is equal to 4. Because we require 4 heads. We require 4 heads. Now, what is the probability? Probability of success, that is getting head. In P, we will write the probability of getting head. So, probability of getting head is 1 by 2. And probability of not getting head is 1 minus 1 by 2. That is again half. Okay. So, first of all, we have to write all these 4 things. Now, we will apply the formula. 10C4 1 by 2 to the power 4 and again 1 by 2 to the power of 6. Now we can solve this and get the result. Now what is 10C4? We have done in permutation and combination chapter. So 10 into 9 into 8 into 7 upon 4, 3, 2, 1. Then multiply by 1 upon 2 to the power of 10. Now we can simplify this and get the result. So 4 can get cancelled with 8. So 4 and 2 got cancelled. Again, we have cancelled this number. So how much we are getting? 210 upon 2 to the power of 10. Okay, and further even we can do some cuttings, cancellation, and then simplify. So we will get the result. So this is the probability of getting 4 heads. So this is the final result, that is 210 upon 2 to the power of 10, or we can say divided by 1024. If we cancel with the help of 2, we are getting 105 by 512. So this is the result. Now there is one most common doubt. एक सबसे जो common doubt यहाँ पर आता है, that I will be discussing here, and that doubt is why we have written half in P and Q. Why we have written half in P and Q? So whenever we are writing this P and Q, we have to write according to one coin. We have to write according to one coin. So if we toss a coin, what is the probability of getting one head? It is 1 by 2. That is why we have written 1 by 2. And what is the probability of not getting head? It is also 1 upon 2. So that is why we have written 1 by 2 here. All right. Perfect. Now let us try some more. Now the next one I am writing about probability of getting at least, or before at least I am giving one more question. Find the probability of getting 2 or 3 heads. 2 or 3 heads. That means this or type of questions we have done in the previous chapter, that is probability. So what we will do, probability of getting 2 heads plus probability of getting 3 heads. We can add them. We can add them. All right. So now we have to solve the question now 2 times. One is for 2 heads, another is for 3 heads. So we can write N, X, P, and Q. N is again 10. We are again tossing 10 coins. Now what is the probability of getting 2 heads? Then X is 2. For head, it is half. Not getting head is also half. So we can solve this here. 10C2, 1 by 2 to the power of 2, and 1 by 2 to the power of 8. This is for 2 heads. Similarly, for 3 heads, 10C3, 1 by 2 to the power of 3, and 1 by 2 to the power of 7. Okay. So how much we are getting now? 10 into 9 upon 2, multiply by 1 upon 2 to the power of 10, plus 10C3, 10 into 9 into 8 upon 3 into 2 into 1, multiply by 1 upon 2 to the power of 10. So how much we are getting? You can compute 45 upon 1024 plus here we can cancel out. 3 got cancelled. This also got cancelled. So we are getting 120 upon 1024. So final result will be 165 upon 1024. So this is the probability of getting 2 heads or 3 heads. All right. So because of or, we have used the addition rule here. All right. Yes. So Priyanka has given the answer. Shiba has also given the answer. Good going. Now we can do the third portion for this question. If the question is asking about find the probability of getting at least 1 head. Now, such kind of questions are most important questions from exam point of view, whether it is a chapter probability or probability distribution. In both the chapters, this kind of question is asked, like what is the probability of getting at least one? So whenever there is at least one, there is one shortcut. There is one shortcut. So we will be discussing the shortcut now. So first of all, we are writing the four values. What is N, X, P, and Q? What is N? 10 coins. What about X? X means the required number. And now what is the required number? Understand this carefully now. It is very much important. In case of any doubt, you can ask once again, but this is very much important portion. So at least one head. At least means what? Minimum. Minimum one head. We are talking about minimum one head. So how many heads we will get? 1, 2, 3, and so on up to 10, because we are tossing the coin 10 times. So we can get head about 1 time, 2 time, 3 time, and so on up to 10 times. Then what is the again probability of success? For head it is half, and not getting head is also half. All right. Now, if we solve in this manner, it will become very much lengthy, because we have to solve for like probability of getting one head plus probability of getting two head plus three head and so on up to probability of getting 10 heads, and this will become very much lengthy. Now, in order to shorten this, what we can do, whenever the question is asking about at least one, we will write probability of 1 minus none. Whenever there is at least one, we will write 1 minus none. Okay, you have to remember this formula. At least one, then 1 minus none. Now, what this none means here? 1 minus probability of getting 0 head. None means 0. 1 minus probability of getting 0 head. So what we are doing? 1 minus. Now, what is the probability of getting 0 head? 10C0. 1 by 2 to the power of 0 and 1 by 2 to the power of 10. Now you can see how much we are getting. 1 minus 10C0 is 1 divided by 2 to the power of 10. So we are getting 1023 upon 1024. So this is the final result. Whenever there is at least one, we will apply 1 minus none. None means probability of not getting head. Okay. All right. So in case of any doubt, you can ask here. Otherwise, we will move forward. Okay. So we have done about 4 heads. Then we have done 2 or 3 heads. And now we have done at least 1 head. Now, what will happen if the question is talking about at least 4 heads? If the question is asking about at least 4 heads, so probability of at least 4 heads. So again, we can write our 4 values, that is N, X, P, and Q. N is 10. Now, what about X? How many heads we are getting? At least 4. So we can write X means 4, 5, 6, and so on up to 10. Up to 10. Then P is half, Q is half. Now, what are the ways to solve this question? Now, there is one way that we can add all these. Probability of 4 heads plus 5 heads and so on up to probability of getting 10 heads. We can add all of them. Now, the second thing, if we don't want to add this, there is some other way also. What are the other ways? See, if we are talking about heads, how many heads in total we can get? Either we can get 0 head, 1 head, 2 head, 3 head, and so on up to 10 heads. These are the all possible cases. That means this is the exhaustive event. Exhaustive means इनके अलावा और कोई event possible नहीं है. So this is the exhaustive. That means the total sum is equal to 1. If there are heads from 0 to 10, then the total is equal to 1. Now what we require from 4 to 10. So we can divide this into two parts. One is probability of getting 0 head, 2 probability of getting 3 heads, plus probability of getting 4 heads, 2 probability of getting 10 heads. Okay, we have divided them into two parts. And our question require to calculate this thing. We want to calculate this thing. So what else can be done here? In order to calculate P4 to P10, we can compute it as 1 minus P0 to P3. Because this whole will get shifted to other side and will be deducted. So we can calculate in this manner: 1 minus probability of 0 head, 1 head, 2 head, and 3 head. Okay, so we can solve in this manner. Ankit says got it. Bhumika says no doubt. Jyoti says all understood. Mohammed says no head means only tail occurs. Perfect, Mohammed. You are correct. Great. So what we are doing now, 1 minus probability of 0 heads, 1 head, 2 head, and 3 head. So we can solve this now. Probability of getting 0 head, 10C0, 1 by 2 to the power of 0, 10, plus 10C1, 1 by 2 to the power of 1 into 1 by 2 to the power of 9. 10C2 into 1 by 2 to the power of 2 and 1 by 2 to the power of 8. And for 3, we can write 10C3, 1 by 2 to the power of 3 and 1 by 2 to the power of 7. Now we can solve all of them and get the result. So 1 minus. Now we can see 1024 is common in all of them. So we can take common 1 upon 1024. So what we are getting? 10C0 is 1. 10C1 is 10. 10C2 is 45. And 10C3. 10C3 we have computed also. 10 into 9 into 8 divided by 6. We are getting 120. So we can solve this. 120 plus 45 plus 10 plus 1 is 176 upon 1024. So what is the final result? 848 upon 1024. Okay, so in this manner we can compute. You can even simplify it after cutting from 4 or 8. All right. So in this manner we can calculate probability of getting at least 4 heads. Now there is a third part as well in this first illustration, which says find out the probability of getting at most 3 heads. At most means maximum 3 heads. So what we will write? X will be 0, 1, 2, and 3. 0, 1, 2, and 3. This will become X. And in the previous question, we have done this calculation. Probability of getting 0 to 3 heads. This we have done just now. So we can write this as 176 upon 1024. This will be our answer. So you can check here 176 upon 1024. All right. Okay, so let me explain once again in Hindi as well. Some of the students are having the doubts. So in the second part में हमें calculate करना था at least 4 heads. At least 4 का मतलब होता है कम से कम 4 हेड, कम से कम 4 हेड। अब कम से कम यानी कि मिनिमम, तो मिनिमम कितने हेड चाहिए हमें? 4, तो 4 से लेकर कहां तक होगा? 4, 5, 6 एंड सो ऑन अप टू 10, 10 तक वो जाएगा। चलो ये हमने लिख दिया। अब प्रॉब्लम क्या है, इनको अगर हम सॉल्व करेंगे तो थोड़ा सा लेंदी हो जाएगा, बड़ा हो जाएगा। तो उसके बाद हमने क्या किया, हमने ये देखा कि सारे इवेंट्स एग्जॉस्टिव जब होते हैं तो उनका टोटल कितना होता है? 1। तो P0 से लेकर के P10 तक उनका टोटल कितना है? 1। नाउ इसको हमने 2 पार्ट्स में ब्रेक कर दिया, बिकॉज हमको 4 से लेके 10 तक का चाहिए, तो 4 से 10 का अलग कर दिया, एंड 0 से 3 अलग हो गया, सेपरेट हो गया। नाउ 0 से 3 को हमने अदर साइड भेजा, एंड फिर वहां हमने सॉल्व कर लिया कि 1 माइनस प्रोबेबिलिटी ऑफ गेटिंग 0 to 3 हेड्स। तो जब हमने उसको माइनस किया तो रिजल्ट कितना आया? 848 अपॉन 1024। नाउ 1024 कैसे आ रहा है? 2 की पावर 10, 2 to the power of 10 is 1024। ऑलराइट, एंड जो थर्ड पार्ट है उसमें सिर्फ क्या पूछा है? 0 से 3 तक हेड आने के चांसेस अगर है, दैट मींस एट मोस्ट 3 हेड्स, मैक्सिमम 3 हेड्स। तो मैक्सिमम मींस 0 से लेकर के 3 तक आ जाएगा। सो वी आर गेटिंग 176 अपॉन 1024। ओके, सो एट मोस्ट मींस मैक्सिमम 3, तो 3 से कम हो सकता है बट 3 से ज्यादा नहीं हो सकता। 3 से कम हो सकता है बट 3 से ज्यादा नहीं हो सकता। ऑलराइट, okay, now let us solve some more variety. Now we are trying example number 2nd. Now the question says, if 15 dates are selected at random, we are selecting 15 dates. Now what is the probability of getting 2 Sundays? Probability of getting 2 Sundays. So let us write all the values first. N, 15 dates are there, N is 15. X, so we have to get 2 Sundays, so required number is 2. Then P and Q, so what is the P? That is Sunday, probability of getting Sunday. What is the probability to get Sunday? It is 1 by 7, because there are 7 days in a week, and out of those 7, 1 Sunday is favorable, so 1 upon 7. Then what about Q? Not getting Sunday, 1 minus 1 by 7, it becomes 6 upon 7. Now we are having all the 4 values, and now we can apply the formula. So 15C2, 1 by 7 to the power of 2, and 6 by 7 to the power of 30. So how much we are getting? 15 into 14 upon 2, multiply by 1 by 49, multiply by 6 by 7 to the power of 30. Now you guys can solve this calculation and get the result. Okay, okay, so Ankit says got it, great. So you can see that this chapter is very much simple and scoring. Just we have to focus on small things. Formulas are also very small. Formula इतनी छोटे हैं कि शुरू होते ही खत्म भी हो जाता है। मीन निकालने के लिए n into p, बस फॉर्मूला खत्म। तो ऑलवेज आपको क्या ध्यान रखना है, बहुत सारी चीजें ऐसी है जो बहुत आसान है इस चैप्टर में, एंड दिस इज वेरी मच स्कोरिंग. ऑन एन एवरेज वी गेट 4 to 5 questions from this chapter. Okay, so understand this thoroughly. So after doing this calculation, you will get the result as 0.29. Okay, you will get the result 0.29. So whenever we are talking about binomial, the most important thing is to write these 4 figures. If we have these 4 figures, after that we can simply apply the formula. So just try to find out these 4 figures first. Okay, so now let us try the next one. The incidence of occupational disease in an industry is such that workmen have 10% chance of suffering it. Now, what is this 10%? 10% is a chance of suffering. That means probability to get infected by a particular disease is 0.1. 10% means 0.1. Then what is the probability that out of 5 workmen, 3 or more will contact the disease? 3 or more will contact the disease. So n. What is n? The question is saying out of 5. That means n is 5. Required number x. X is 3, 4, 5 because question is talking about 3 or more. So 3, 4, 5. Okay. Then what is p? Probability of getting affected by disease is 0.1 and probability of not getting affected by disease, it will become 0.9. And now it is very much easy. We can apply the formula and get the result. So 5C3 into 0.1 to the power of 3 and 0.9 to the power of 2 plus we can say 5C4 0.1 to the power of 4 and 0.9 to the power of 1 plus 5C5 0.1 to the power of 5 and 0.9 to the power of 0. Okay, now you can solve this and get the result. Shiva has given the answer. Chandan has also given the answer. Great. Okay, so now after adding, you will get your final result. So what is the result? 0.0086. 0.0086. This is the final result. Okay. All right, everyone. Now we are moving towards the fourth example. Now what this fourth example is about, find the probability of success for binomial distribution satisfying the following relation. Now there is some relation and which is having the parameter n as 6. The value of n is given as 6 and this is the equation. So see, it is very much easy. What we have to do, just apply the formula for binomial. Just apply the formula for binomial. So 4 multiplied by. So since n is equal to 6, we can write ncx to 6c4. P is not available, so we will write p to the power of 4. Q is also not available, so we will write 6 minus 4, that is 2, equals 2. Now x is 2 to 6c2, p to the power of 2 and q to the power of 4. Okay. Now in combination chapter we have discussed that 6c4 and 6c2 both are equal. They will get cancelled. P to the power of 4 will also get cancelled with p square. Q square will get cancelled. So what we are left with now, 4p square is equal to q square. Now we can take square root on both the sides. So 2p is equal to q. 2p is equal to q. And what we have to calculate? Find the probability of success. Success means p. So p we have to calculate. So we know that q is equal to 1 minus p. Q can be written as 1 minus p. So we can write here 2p is equal to 1 minus p. So 3p is equal to 1 and final probability will be 1 divided by 3. 1 divided by 3. So this is the final result. So in this way we can calculate. All right. this is the next pattern which is asked in binomial. So one was to calculate the mean, variance, and standard deviation. Second pattern was to calculate the probability. And the third question is, with the help of this equation, we have to calculate the probability of success or failure. If you are supposed to ask Q, then what we have to do? 1 minus 1 by 3, it will become 2 by 3. Okay. Now, the next one, find the binomial distribution for which mean and standard deviation are 6 and 2 respectively. Now, the question is giving some figures. One is mean and second is standard deviation. Mean is 6, standard deviation is 2. Okay. Now, what we have to find out? The binomial distribution. So what we have to do, mean is equal to, the formula for mean is equal to n into p, and the value is 6. For standard deviation, we can say that it is root of npq and the value is 2. Now what we can do, we can squaring both the sides. So npq is equal to 4, and we are having the value of np. What is the value of np? It is 6. Value of np is 6. So in place of np, we can write 6. So 6q is equal to 4. The value of q will become 4 by 6, or we can say 2 by 3. 2 by 3. So this is the value of q. So now first of all, we have find out the value of q. Now we have to calculate the value of p. For p, we can do 1 minus 2 upon 3. It will become 1 by 3. So now p is also available. Next, if we have to calculate n. So if np is equal to 6, now n multiplied by 1 by 3 is 6. So what will be n? It will become 18. The value of n is equal to 18. So in this way, we can find out all the figures. Okay. We can compute all the figures. So n is 18, p is 1 by 3, and q is 2 by 3. And now, if the question is talking about find out the probability mass function, that means we have to just write a formula. We have to just write a formula. So what is the formula for probability? It is NCX, p to the power of x, and q to the power of n minus x. We are having all the values except x. So we will substitute the given values. 18cx, p is 1 by 3 to the power of x, and q is 2 by 3 to the power 18 minus x. So this is the final answer, where the value of x will lie from 0, 1, 2, and so on till n, that is 18. The value will lie till 18. All right. So this is probability in case of binomial distribution. Now we are doing first example number 7. Example number 7. 6 coins are tossed 512 times. How many coins we are tossing? 6 coins. And that too 512 times we are tossing. Find the expected frequency of heads. We have to find expected frequency of getting heads. That means how many times we will get head. Also compute mean and standard deviation for the number of heads. So we have to find frequency, mean, as well as standard deviation. All these 3 values we have to calculate. So let us begin this. See, first of all, we can write all the given figures. What are the given figures? One is n, x, p, and q. Now there can be one confusion, that is what we will take n, 6 or 512. 6 or 512, what we will be taking n. So we can say that we are tossing 6 coins 512 times. So both of these are n, but there is one difference. What is the difference? Like there is one small n and other one is capital N. Because since we are tossing 6 coins at a time, so small n is equal to 6. And that thing is repeated 512 times. Like 1, 2, 3, 4, 5, 6. 6 coins tossed one time. Again, second time we have tossed 6 coins. Third time also we have tossed 6 coins, and so on up till 512 we have done. So these 6 are known as the small n, and these 512 is known as capital N. This capital N will help us to calculate the frequency, and the small n help us to calculate the probability. All right, small n is used for probability and capital N is used for frequency. So we can write all these figures. 512 is capital N, 6 small n. Required number, what is required? Then we are, if it is not available, we can take it as x. Then P is 1 by 2, Q is also 1 by 2. Q is also 1 by 2. Now, since x is not given, that means we can use all the figures 0, 1, 2, 3, 4, and so on up to 6. So now see what we have done here. We have taken x, that is all possible cases. All possible cases. So x is, we are talking about heads. So how many heads we will get? 0 or 1 head, 2, 3, 4, 5 or 6 head. So we can get from 0 to 6 heads. Then what is the probability of getting 0 head? So 0 head we can simply calculate as 1 by 64. 1 head, 6 by 64. How we are calculating this? We have done this in the beginning of the session. That is probability of calculating 1 head, 2 head, 3 head, and so on. We can calculate in that manner. Okay, this is 0 head, 1 head, 2 head, and so on. So this is the probability. So we are having x, we are having p. Now if we have to calculate the frequency, expected frequency, then what we have to do? We have to multiply them. We have to multiply them, that how many times we are getting, 0 heads, 1 heads, 2 heads, and so on. So we can do this simply. 512 multiplied by 1 by 64. Then 6 by 64 multiplied by 512. So by multiplying the frequency with capital N, we will get the required frequency. We will get the required frequency. So simply what we have done? We have done frequency is equal to capital N multiplied by the probability. And we are getting the frequency for each one of them. Okay. Now, in the previous chapter, if you remember, you have done expected value. And what was the formula for expected value? It is summation of P into X. And expected value is nothing but the mean only. So it can be denoted with the help of mu. So if we multiply this P and X, Fx here means probability. So if we multiply P and X, we are getting 3, and this 3 is nothing but the mean. Okay, with the help of this expected value formula, we can calculate the mean. Okay, or if we talk about in this terms, then it is n multiplied by p. So again we are doing the same. N is number of heads and p is the probability. So if we multiply them, we will get the mean. And secondly, if we are talking about variance, how to calculate the variance. So there is one formula, expected value of x square minus expected value of x ka whole square. So in this manner we can do, but this question is not meant for examination. This is a purely theoretical question just for understanding purpose, but such kind of questions are not asked in examinations. All right, only you can get a part of these questions which we have discussed till now. Okay, but this type of whole question is not possible because we are given the options and here we are preparing the complete table. All right, so no need to worry. Okay, Harshit is asking about how we are getting fx. Yes, Harshit, here fx means probability. And for probability, you are having n, x, p, and q, and apply the formula. You will get the result. Okay. So if we are talking about directly how to calculate mean, so we know that the formula for mean is n into p. So there is small n as 6 and probability of getting head is half. So mean is 3. And if we have to calculate the standard deviation, then the formula is root of NPQ. So 6 into half into half. So we are getting 1.22. This is the standard deviation. Okay, all right. So now we have done till 7th illustration. We will take a small break now and we will continue after 5 minutes. So let's take a 5 minutes break and we will be back in 5 minutes. All right. Till then you can have your water, snacks and come back after 5 minutes. So welcome back everyone. So now we have done till 7th question. Now we are moving towards some other questions. So now the most important thing is to calculate. What we are calculating here, the probability. Now how to calculate the probability? For the calculation we have to find out only the 3 figures, and with the help of all those figures we can compute. Okay, so let us move towards the next point. One second. I think there is some error here. Give me a second, guys. I will reopen this file. सर आप 2 मिनट्स का एक बार ब्रेक लगा दीजिए, मैं इसको एक बार सेट करता हूँ. So welcome back now. So now we are talking about the next question, that is question number 8. Now this question says an experiment succeeds thrice as after it fails. Now the most important thing here which is given is the ratio. We have to calculate in terms of ratio. There is success and failure. So the ratio for success and failure is 3 is to 1. 3 is to 1. If the experiment is getting repeated 5 times, the experiment times, then what is the probability of having no success at all? So we can write n will be 5, then p, q, and then x. We are repeating the experiment 5 times. Having no success. No success means the value of x will be 0. The value of x will be 0. Then what is the p and what is q? From success and failure ratio, we can calculate p as 3 by 4 and failure as 1 by 4. 3 upon 3 plus 1 and 1 upon 3 plus 1. So in this manner, we can calculate n, p, q, and x. Now, since all the 4 are available, we can calculate probability. In this was to compute the value of p and q here. All right. Okay, so now we are doing the next example, which is 10. Yes, we are taking 10. If x and y are two independent variables, these are two independent binomial variable having parameters 6 and 1 by 12 and 4 and 1 by respectively. Now let us understand about the parameters first. What are parameters? What are parameters? So parameters is n and p. These are the two parameters. N and p are the two parameters for binomial distribution. Now parameter हम किसे कहते हैं? वो elements जिसकी help से हम बाकी सब कुछ find out कर सकते हैं. That is known as parameter. That means with the help of n and p, if n and p are available, and with the help of these two, we can calculate mean, variance, standard deviation, and probability. Then these are known as parameters. So here have the two values, that is n and p. These are known as parameters. So n is given as 6 and p is given as n is 6 and p is given as half. This is for x. Similarly, for y. For y, we are having n is 4 and p is half. P is half. Okay. So these are two independent binomial variable. That means we can say that x is following binomial distribution. Y is also following binomial distribution. Now, what are the parameters? 6 and half, and the parameters for y is 4 and half. Now, what the question is asking to us? Now, what is the probability of x plus y greater than equal to 1? Now, the question is talking about this thing. What is the probability of x plus y greater than equal to 1? Okay, so whenever we are given these two kinds of variables, variable x and variable y, and if we have to calculate where So we were talking about like if X is following binomial distribution, Y is also following binomial distribution, then X plus Y will also follow binomial distribution, and the parameters will be 10 and half. 10 and half. Now these are the parameters. Now what we have to calculate? We have to calculate the probability. So for calculating the probability, we are having n. We are having mean as 10, and also what we are having probability. Probability is 1.5, that is 1/2. So what simply can be done? 1 minus probability of none. Why we are doing this? Because we are asked X plus Y should be greater than or equal to 1. So for more than 1, what we can do? 1 minus none. 1 minus none. None means 10C0, 1/2 to the power of 0, and 1/2 to the power of 10. So we will get 1 minus 1 upon 1024, that is 1023 divided by 1024. Okay, so let us understand this question once again. In this question, we are given two independent binomial variables which are having different parameters. Now we have to calculate the probability of their sum. We have to calculate the probability of their sum, and what is the requirement? Their sum should be greater than or equal to 1. Greater than or equal to 1. So whenever X is greater than or equal to 1, that means 1, 2, 3, and so on up to n. So what we will do? 1 minus probability of none. We always do 1 minus probability of none. So in this case, when we are talking about none, none means X will be taken as 0. So what we have done? 1 minus 10C0, then P to the power of 0. P is half and Q is also half. So finally we are getting 1023 upon 1024. Okay, 1023 upon 1024. This is the final result. Now let us do some questions from the back, that is from set ABC. So these are some Poisson and normal distribution which we will be discussing in our upcoming sessions. But in today's class, we are only talking about the binomial distribution. Okay. So now we are moving towards the back exercise questions. Okay, let us take some questions from here. So I'm taking some random questions which are more important or more relevant, which will be difficult for you to do self. So I will be discussing some of the important questions from back. Let's take question number 8. The important characteristics of Bernoulli trial. What is the important characteristics of Bernoulli trial? First option says each trial is associated with two possible outcomes, that is success and failure. Yes, A can be correct. Second, trials are independent. This condition is also correct. Third, trials are infinite. No, trials are not infinite. So A and B are correct, and this is written in option number D. Both A and B. Both A and B. Then ninth one, the probability mass function of binomial distribution. Now for probability, we have discussed the formula. So which one is correct? Option number B. It is already clear. Then 10th one, if X is a binomial variable, with parameters n and p. These are the parameters. Then x can assume value. The value of x will lie from 0 to n and both will be inclusive. Let's say we have taken 10 coins. The number of heads can be 0, 1, 2, 3 and so on up to 10. So 0 is also inclusive, 10 is also inclusive. But option number B does not say whole number, because the n should always be in terms of whole numbers. So option number C is more appropriate. Any whole number between 0 and n and both inclusive. So option number C will be correct. Then a binomial distribution is symmetrical or positively skewed, negatively skewed, or symmetrical when p is equal to 5. Now we are talking about the symmetricalness. Now when we say that the distribution is symmetrical, so if we draw this kind of curve, this is a normal distribution curve, or we can say a symmetrical curve. This curve is symmetrical. Okay, this is a symmetrical curve. Now what this symmetrical means? Symmetrical means the area on both the sides is equal. Area on both the sides is equal. That means the probability of success and probability of failure is also equal. That means half, or we can say 0.5. Probability of success and failure both are same. That is known as symmetrical. And if the probability of success is, let's say, 0.6, then Q will automatically become 0.4. If these two are not same, that means the distribution will be not symmetrical, or we can say asymmetrical. Okay, so if both are equal, it is symmetrical. If both are unequal, then it is asymmetrical, or we can say not symmetrical. All right. So here the binomial distribution is symmetrical only when p is equal to 0.5. Then the 12th one, the mean of binomial distribution with parameter n and p is. We have to calculate the mean. The formula for mean is n into p. Option number C. Then 13, variance. Now the formula for variance is NPQ. But all these options are not showing NPQ. But there is one option which is showing NQ and 1 minus Q. So we know that 1 minus Q is nothing but P. For a binomial distribution, mean and mode are equal, or are always equal, never equal, or when Q is 0.5, then it will be equal. So see, when we were talking about central tendency, these points were discussed in the topic central tendency. Like whenever a distribution is symmetrical, in case of a symmetrical distribution, mean is equal to median is equal to mode. All these three are equal. In case of symmetrical distribution, all these three are equal. And when this will be symmetrical, when P and Q both will be 0.5. So we can say which of the option is correct? Option number C. Like mean and mode will be equal, but when Q is 0.5. Okay. Then 16th one, the mean of binomial distribution is more than variance, equal to variance, or less than variance. So if we compare the formula, mean and variance, the formula for mean is n into p, and formula for variance is npq. Formula for variance is npq. So if we compare, which one will be greater? Mean will be greater. Mean will be greater. Why so? Just we have taken the example, like there were 30 dice. We have thrown 30 dices, and we have to calculate the mean for getting number of sixes on the dice. So 30 into 1 by 6. How much we are getting? 5. If we have to calculate the variance for the same situation, like 30 times we have thrown the dice, then probability of getting number 6 is 1 by 6, and probability of not getting number 6 is 5 by 6. So we can say that how much we are getting? 25 by 6. So it is 4 point something. So 4.2 roughly. So which one is greater? Mean is greater. So whenever we are talking about binomial distribution, mean is greater than variance. Mean is greater than variance. So we can take option number A. Mean is always more than its variance. Now, what will be the maximum value of variance? So when P and Q both are equal, that means 0.5, or we can say 1 by 2, then variance is maximum. When P and Q both are equal, then variance will be maximum. And what will be that maximum value of variance? So formula is NPQ, n multiply by half multiply by half. It becomes n by 4. So maximum value of variance is n upon 4. Maximum value for variance is always n upon 4. Okay, but it will happen only when P and Q both are equal. So for 18th, we will take option number B. Option number B. Question number 17 we will be doing in a moment, but before that we are doing the next question, 19th. The method usually applied for fitting a binomial distribution. So always what we say, we have to learn one name which is known as the method of moments. This method is used for fitting the binomial distribution. So whenever there is one question like which of the method is used for fitting a binomial distribution, then it is known as method of moments, or we can say the moments method. This is used for binomial distribution. It is simply the name of the method. So it is simply a theoretical question. Now the next part is how to calculate mode in case of binomial distribution. So we are writing calculation of mode. Calculation of mode in case of binomial distribution. Binomial distribution. So how to calculate this mode? So whenever we are talking about mode, there is one condition. What is the condition? Let us write down. If n plus 1 into p is a whole number. If n plus 1 into p is a whole number, say k, like k, then mode is equal to k and k minus 1. mode will be equal to k and k minus 1. This is the first condition. And second, if n plus 1 into p is not a whole number, it is not a whole number, like say k plus f, that is, it is in terms of fraction, then the mode will be equal to just k. Mode will be simply k. Okay. So if we are talking about, let's say, if n plus 1 into p is 6, if n plus 1 into p comes out as 6, then mode will be 6 and 6 minus 1, that is 5. But if n plus 1 into p is 5.5, then mode will be simply 5. We have to ignore this decimal value. We have to ignore the after decimal value. Just we have to take 5. So 5 will be the mode. So in case of binomial distribution, there can be one mode or there can be two mode. If n plus 1 into p comes out as a whole number, then there are two modes, k and k minus 1. If it is not a whole number, then there will be a single mode, that is k. All right. So now we can discuss question number 17 as well. 17 says, for a binomial distribution, there may be how many modes? 1 or 2? Option number D, it can be either one mode or it can be two modes. Okay. Then we are moving towards B part. Yes. Set B. Question number first. What is the standard deviation for the number of recoveries among 48 patients when the probability of recovering is 0.75? 0.75. So what we can do? What is given to us? There are 48 patients. This 48 is n. Probability of getting recovered, it is p. It is p, 0.75. And we have to calculate the standard deviation. So formula for SD is root of NPQ. So 48 multiplied by 0.75 multiplied by Q. What is Q? 0.25. So we can solve this. So 48 into 0.75 into 0.25. How much we are getting? 9 root, and root of 9 is 3. So correct answer is 3. Okay. So correct answer will be 3 in this case. Now, come on, everyone. You have to answer question number second. I'm waiting for your answer. Question number second says, X is a binomial variable with n is 20. So n is given now. N is given now, and you have to answer what? That what is the mean of X if X is symmetric? You have to find out the mean. So for calculating the mean, we must have the value of P, probability. So what will be the probability? Because the distribution is symmetric, probability will be 0.5. So mean is equal to 20 into 0.5. That is 10. Option number B. Option number B will be correct. Priyanka has given the answer. Bhumika, Jyoti, Vinita, Shiva. Great. Then the next one. The third one, X follows. This sign is for follows. X follows. B is for binomial distribution. In bracket, there are two values. These two are parameters. One is n, second one is p. What would be the greatest value of variance? We have read now maximum variance is always equal to n upon 4. Maximum variance is n upon 4. So what is n here? N is 16. So 16 divided by 4 is equal to 4. So 4 will be the correct answer. 4 will be the correct answer. Then the next one. Yes, Chandan is also given. Mansi, Ankit, Muhammad Ali. Great. Now, fourth one. If x is a binomial variate with parameter 15 and 1 by 3, these two are the parameters. So 15 is n and 1 by 3 is p. What is the value of mode? So we have just understood the concept of mode, that is n plus 1 multiplied by p. So 15 plus 1 multiplied by 1 by 3. How much we are getting? 5.33. So what will be the mode? We have to ignore after decimal value. So mode will be equal to 5. Mode is equal to 5. Okay. Option number B. Next one. Next one says, what is the number of trials? We have to find out the number of trials. That is n you have to find out, having mean as 3 and standard deviation as 1.5. So this pattern also we have covered. You can solve this. So mean, that is n equal to 3 and mean is 3. Standard deviation NPQ, root of NPQ is 1.5. And here we have to calculate the value of n. So squaring both the sides, we are getting NPQ is equal to 1.5 square. In place of NP, we can write 3. So 3Q is equal to 1.5 square. So finally, what we are getting? 1.5 into 1.5 upon 3. Upon 3. So we will get the value of Q. So 1.5 by 2 is 0.75. So 0.75 is Q. 0.75 is Q. What about P? It will be 1 minus 0.75, that is 0.25. And finally, we have to find out N. So N multiplied by 0.25 is 3. So N is equal to 3 upon 0.25. Result will be 12. Value of N will be equal to 12. Yes. So Achal has given, Manisha, Vinita, Bhumika, then Dhanesh. Good going. So this was the correct answer. Now the next one. Sixth, you can do yourself. It is easy. 7 is easy. Eighth one, I am sharing what is NXPNQ, and rest you can try it yourself. What is the probability of making 3 correct guesses in 5 true-false answer type questions? 3 correct guesses out of 5 true-false answer type question. So what is N? 5. X is 3. Now, since it is true-false type question, that means 1 by 2 is the probability of giving correct answer, and 1 by 2 will be the probability of giving the wrong answer. So P and Q both are half and half. half and half. All right. Now you can apply the formula and get the result. So 5C3, 1 by 2 to the power of 3 and 1 by 2 to the power of 2. Okay, so now you can solve this question. So 5C3, 5C3 is how much? 5 into 4 into 3 upon 3 into 2 into 1 multiply by 1 upon 2 to the power of 5. So how much we are getting? 10 upon 32, or we can say 5 by 16. So 5 by 16 will be the correct answer. 5 by 16 will be the correct answer. All right. So overall, in this first section of binomial distribution, what we have discussed, we will just brush up in last 5 to 10 minutes. Okay. So theoretical frequency distribution, also known as probability distribution. So in this chapter, we have to find out the probability as well as the theoretical frequency. Okay. Now this chapter was divided into two parts. One is discrete distribution and second one is continuous distribution. Under discrete, there are two types of distribution. One is binomial and second one is Poisson. Under the continuous, there are many kind of distribution, but we have to study only normal distribution. All right. Now we have started with the binomial distribution today. Now for binomial distribution, there are four basic conditions where which we have to see. The first one is the number of trials, that is n. N is always a finite number, a positive number, and it should be a whole number. Okay, that is number of coins should always be positive, a whole number, okay, and a finite number. Then second one is always we have to consider those cases which are independent of each other. Only those cases will be considered which are independent of each other. Okay. Then third condition was there are only two outcomes, that is success and failure. And these two outcomes are mutually exclusive. These two outcomes are mutually exclusive. That means only one at a time can occur. Only one at a time can occur. So these two are mutually exclusive and also they are exhaustive. So sum of P and Q is equal to 1. Sum of P and Q is equal to 1. So these are the basic conditions. Now there are some formulas which we have done for binomial distribution. One is mean. Now the formula for mean is very much simple. That is n multiplied by P, probability. For variance, what we have to do? N into P into Q. We have to multiply all these three. For standard deviation, we have to multiply root of NPQ. Just take the square root of variance and we will get the standard deviation. And the fourth formula was to calculate the probability. That is NCX, P to the power of X and Q to the power of N minus X. So what is the most important thing? What is the most important thing for calculating the probability? That is the four values, N, X, P and Q. If these four values we are able to find out, then it is sure we will be able to calculate probability. Okay. Then we have also discussed some of the theoretical points. That is, if P and Q both are equal, if probability of success is equal to probability of failure, then the distribution is known as symmetrical distribution. Symmetrical distribution. And if both are unequal, if P is not equal to Q, that means the distribution will be asymmetrical. It will be asymmetrical. Then when there will be a maximum value of variance, if P and Q both are equal, if P and Q both are equal, then the value of variance will be maximum. And that maximum value will be 0.5. That maximum value will be n by 4. Okay. So when P and Q both are equal, then variance will be maximum and that maximum value will be n upon 4. Okay. Then we have understood one more property, that is if X follows binomial distribution with parameter n and p. Y also follows binomial distribution with some parameters, then X plus Y will also follow binomial distribution. And the new parameters will be the addition of n and with the probability. N1 plus N2 comma the probability. This will be the parameters of X plus Y. Okay. So all these theoretically we have done. And let's see what are the doubts. Yes, two outcomes, success and failure, only one can occur, right? Yes. So Shiva is asking about, okay, Shiva is giving the summary points. So she is correct. Variance is NPQ. Yeah. Okay. So in case of any doubt, you can comment down and we will be discussing those doubts as well. No need to worry. So what you have to do today, you have to solve each and every illustration and questions given in your study material from the topic binomial distribution, so that you can apply today itself and you will you will see that you will be able to solve each and every question very easily. Okay, because आज के सेशन में हमने काफी डिटेल से और काफी बारीकी से सारे पॉइंट्स को डिस्कस किया है. But I think आपसे ये सारे क्वेश्चंस हो जाएंगे. In case of any doubts, you can let us know और हम वो सारे डाउट्स भी नेक्स्ट सेशन में डिस्कस कर सकते हैं. ओके, बट इट इज मोस्ट इंपॉर्टेंट कि आप सारे क्वेश्चंस की प्रैक्टिस करें और जो भी आपके डाउट्स होंगे वो हम नेक्स्ट सेशन में करेंगे. सो इन द नेक्स्ट सेशन एज वेल वी विल बी डिस्कसिंग अबाउट द पॉइसन डिस्ट्रीब्यूशन. Jyoti says saying all understood. Great. And one more topic which we have discussed today, that is calculation of mode in case of binomial distribution. So for mode, what was the formula? If n plus 1 into p is a whole number, then there will be two modes. One is k and second one is k minus 1. But if it is not a whole number, then there will be a single mode, that is k. There will be single mode, that is k. So this also we had done. Then there are one mode, or it can be two mode. It can be unimodal or bimodal. Unimodal means one mode, single mode. Bimodal means two mode. Okay, so there can always be one mode or even two modes. Okay, so I think we have covered all the things which are from binomial distribution, and you can try today itself, and we will discuss in our next session whatever are your doubts, whatever are your problems, we will be discussing with Poisson distribution, and then in the third session we will be doing normal distribution. All right, and now also those who are giving examination in May attempt, it is very much important to fill the examination form. So if you have not filed, then of course you can fill with the online mode. Okay, so every detail is available in on the website of the institute, so you can go through them and fill your examination form. Okay, Bhumika is asking about probability distribution exists in real life or not. See, when we are talking about real life, so we always apply probability in our life. Let's say it is a rainy season and we have to go out to the market. So we decide, we look at the sky and see how much is the probability to get rain. Or what we do, we like ask with the help of like weather forecast, we ask the Google like how much are the chances of getting rain today, and accordingly we make the decision. So in our practical life, we always use probability, and in many businesses, especially for forecasting purpose, probability is used. Like what will be the sales forecast, what will be the demand forecast. Even government also uses in many of the places, like what will be the situation of population after 10 years, 20 years, and many other factors are there which we have to judge, which we have to forecast. So always probability is used in our practical life. Okay, so all this we have done today. So bye everyone, take care and see you in the next session. Bye bye.